Okay, so yesterday we talked about the normal curve and how the data lines up on the normal curve. We learned that 68% of the data it was within the first standard deviation, that 95% of the data is within 2 standard deviations of the mean. This is the mean value. And 99, almost all the data is within 3 standard deviations of the mean. So a z-scores is what we're going to talk about today. And z-scores are essentially these numbers right here. A z-score tells you how many standard deviations that a data value is from the mean. If a z-score is positive, the data falls above the mean. So it would be right here. Above the mean if it's a positive z-score. If the z-score is negative, then the data falls below the mean. So there's a formula that we use to find the z-score. So we have to learn these variables. Z is the z-score. Z, and that's how I write z, equals, and it's the mean, it's the actual value that we're talking about, minus the mean, there's the symbol for mean, divided by the standard deviation. So the value that we're examining minus the average or the mean divided by the standard deviation. Okay, so let's work with some of these. The weights of 6-month-old baby boys are normally distributed, so we can use this with a mean of 17. So let's write our symbol, mean of 17, and a standard deviation of 2 pounds. Mrs. Lohman's son Andrew weighed 22.2 pounds. That's a large child. X, that's what he weighed when he was 6 months old. What is Andrew's z-score? So we're going to write the z-score for Andrew equals his value, his weight, 22.2, minus the mean of 17 divided by the standard deviation, which we've said is 2 pounds. So we're going to use our calculator. We're going to work that out, and we're going to get 22.2 minus 17 divided by 2. And we're going to get a z-score of 2.6. So that's Andrew's z-score. So Miss Snyder's nephew, Dominic, weighed 13.2 pounds. That's his X when he was 6 months old. What is Dominic's z-score? So the z-score for Dominic equals 13.2 minus the average, so he's below average, divided by the standard deviation. And when we work that out on the calculator, we get a score of negative 1.9. So whose weight is more unusual? Another way to ask that is whose z-score is farther from the mean? Whether it's positively or negatively, who's farther away? Well, Andrew is farther away. Andrew is more unusual. Andrew is more unusual because his z-score is further from the mean. Okay. So what value are these z-scores? Well, let's talk about what we do with z-scores. We need z-scores when we need to standardize. Okay, there's a perfect example coming up. When you convert data into z-score, this is called standardizing. Standardizing. Which is useful for comparing data with different scales. And so we're all familiar with the fact that, standardizing with different scales. We're all familiar with taking SAT scores versus ACT scores. So how do you compare somebody who's only taken the SAT to somebody who's only taken the ACT? Who did better? Let's do it. Okay, so we have who take SAT, now suppose the average SAT score, so the mean, mu of SAT is 1500 with a standard deviation of 300. The ACT has an average of 20.6 and a standard deviation of 5.2. So we've got those set. Now let's compare Bobby and Gina. Bobby took only the SAT and got an 1810. So let's do the Z-score for Bobby. So Bobby had a score of 1810. Now we have to look at he's an SAT guy, so the mean SAT is 1500. So it's 1810 minus 1500 divided by the standard deviation for SAT scores, which is 300. Okay? Now we're going to set up the Z-score for Gina. So Gina took the ACT and got a 28. That's her X. Minus the average. Average is 20.6. Looks like they both did above average. Divided by the standard deviation of 5.2. So now I'm just going to do this on my calculator. 1800 minus 1500. So 290 divided by 300 is equal to 1.033. Sorry, this is 310 divided by 300. 28 minus 20, that's positive. It's going to be a positive Z-score, and this is going to be 1. So the Z for Gina is going to be example 2. Peter took an SAT and got a 1325. SAT 1325. Sarah took the ACT and got a 19. Which student performed better? So you could take a guess. Who do you think did better? But let's find out for sure. The Z-score of Peter equals his score, 1325, minus the average SAT score, which was 1500, divided by the standard deviation for SAT scores, 300. The Z-score for Sarah is equal to her score, 19, minus the average, which was 20.6, divided by the standard deviation, 5.2. Now, this is going to be a negative Z-score because I'm going to have a negative divided by a positive. This is also going to be a negative. So, always a good idea to see what you're expecting. So, when I do this on my calculator, I get negative 0.58. So, I am this far from the mean in the negative direction. The Z-score for Sarah is negative 0.31. And so who did better? Well, now in this case, we have to say, okay, Peter is farther from the mean, but he's farther from the mean in a different direction. So if the question is asking you who did more unusually, it's Peter. But the question is asking us which student performed better. So Sarah performed better. Sarah performed better. Okay, so what I'd like you to do is do this same, find the Z-scores for this problem. I want you to do this problem on your own and see how you do. We'll check it in class. So you've got batting averages of Ted Williams and I don't know how to say his name. Nomar Garciaparra? I'm sure you'll tell me. Okay, I'll see you tomorrow.